another example, as we're looking at graphs of functions and equations, is something with an equation that looks like this: y equals x raised to the second power. Well, right away we should be thinking that this isn't going to be a straight line because it's not an exponent of 1. So let's see. So what we have here is an input-output table with some inputs that we're going to be graphing. And then we got to figure out what our y value is. So basically what we're going to be doing is we're just going to be plugging these numbers right in here for x. So I would say 0 to the second power. Well, that's 0. And I would say 1 to the second power. 1 times 1 is 1. 2 to the second power. 2 times 2 is 4. 3 to the second power. 3 times 3 is 9. And hopefully you kind of get the idea. 6 times 6 is 36. So we get a quick input-output table here. And then what that leads to, we don't necessarily have to write it like that as long as we understand it, is ordered pairs. And what we can do with these ordered pairs then is we can put them on the graph. So I'm going to go ahead and do that now. We have 0, 0. We have the point 1, 1. Now, always be careful to look at your scale. If I look down here on my x-axis, I have 1, 2, 3, 4. If I look here, though, I have 2, 4, 6, 8, 10. So I can't just go over one block and up one block because that's actually the ordered pair 1, 2. So I'm going to just go 1, 1. And then I'm going to have 2, 4, 3, 9. Same thing in between the 8 and 10 here. 4, 16. 5, 25. You can see why they started, or they went by a scale of 2 because it jumps pretty quick here. 6, 36. Now, if you look at it closely, you can see that this really isn't a straight line. It has this curve to it, which I don't do real well drawing. Not bad. Okay, but you can see that there's a curve to it right here. So what shape does it appear to take? Well, it's a curved shape. It's a U shape. It's something we call a parabola. A parabola. It's parabola. And what we would see is if we came up here on the other side, it would actually going back up. Why? Because if I had negative 1 in this input-output table, I would do negative 1 squared. Well, negative 1 times a negative 1 is a positive 1. If I did negative 2, I'd do negative 2 squared. Negative 2 times negative 2 is 4. So you're seeing we're getting the same outputs. So it's going to start coming back up over here. Is this equation a linear equation? No. Explain? Well, remember, we actually have two types of explanations. We knew right off the bat that it wasn't a linear equation because we had an exponent other than 1. And the other reason we know